Hello again. This is our second lecture. This is sort of an introduction to section 3.2. This is Dr. Maxwell's version of a very famous story about the Hotel Infinity, which is attributed to a German mathematician, David Hilbert. He was one of the greatest mathematicians of the 19th century. Now, in the Hotel Infinity, there are room numbers that start at 1, and they go on forever, as you might suspect. There are an infinite number of rooms in the Hotel Infinity, one room for each natural number. And there's a manager, and he has this very challenging task. There's always a vacancy, and yet he always has to ensure that the hotel is fully occupied. So there are an infinite number of rooms. This goes on forever. And let's see what happens. Okay. Right now, the hotel is fully occupied. Who's in there? This infinite women's volleyball team known as the Supernaturals. So these are their jersey numbers. They wear jerseys that correspond to the natural numbers. So putting them in rooms was really easy. The manager just said, you go in the room that corresponds to your jersey number. Player 1's in room 1, player 2's in room 2, and so on. There's a one-to-one correspondence between the jersey numbers and the rooms. We know who is in each room, and we know where each player is staying. So we have a one-to-one correspondence. Everything's fine. Until Coach Zero shows up. Now she wears a jersey that has a 0 on it, and she has been out celebrating the team's recent victory, and now she demands her own room. She is not going to share a room with someone. So the manager stops and thinks about this for a minute, and he says, don't worry, I took Math 154. I know what to do. He also, this helps a lot, he has a very special cell phone, and he can send an infinite number of texts at once. And this is what he sends to each player. He texts each player, hey, sorry, but I need you to move down one room. So what does that mean? Well, player 1 will move to room 2. Player 2 will move to room 3, and so on. Everybody just moves down one room. And now, Coach Zero can go in room number 1. And we still know exactly who's in each room, and we know which room corresponds to each person. So everything is fine. Hotel's full. We know where everybody is. For example, if you wanted to know who's in room 1000, well, you just figure it out. That's player who wears the jersey 1001. The manager knows who's in each room. Everyone has a room, and every room is occupied by one person. We still have this one-to-one correspondence. Between the jerseys, including 0, and the rooms. All right. So just when we thought everything was fine, something else happens. In the morning, the infinite men's lacrosse team, the negators, show up. These guys, they wear jerseys that have negative numbers on them. So the jerseys go -1, -2, -3. Remember, this is an infinite team, so these go on forever. Um, so we need an infinite number of rooms for these guys. We're not going to make people share. It has to be one room for one person. Well, remember, this manager took Math 154 at the University of Montevallo, and they can figure out what to do. He writes a new text that he can send out instantly to all the volleyball players. It says, look at your jersey number, multiply that by 2. That's going to be your new room assignment. All right, so what does that mean? Well, player 1 looks at her jersey number. Oh, well, she remembers what it is. If you multiply that by 2, you get 2. Well, player 1 is already in room 2. Player 1 does not have to move. What about player 2? Well, if you multiply 2 by 2, you get 4. So player 2 has to move down one room. Player 3, well, they need to go to room 6. Player 4, multiply that by 2, you get 8. They need to go to room 8. Player 5 will be going down to room 10, and so on. So let's see what good this did. All right. Now we have all the odd numbers rooms are empty except room 1. But here are the empty rooms. So we have 3, 5, 7, 9, and so on. The volleyball players are all in the even numbered rooms. So the lacrosse players, the negators, they can go into this infinite number of odd numbered rooms. All right, let's see what happens. Well, how are we going to assign rooms to these players? Of course, for the first few, you can say player -1 goes into room 3, player -2 goes into room 5, player -3, they would go into room 7, but you can't keep doing this because there are an infinite number of players. So you can't just hand them out keys and say, go to this room. We need some systematic way to tell them which room to go to. So what can he tell the lacrosse players? Well, we're going to go back and remember Poya. Let's make sure we understand the problem. And perhaps a table will help. And I have made us a table. Here are the room numbers. Here are the jersey numbers. So we know who's in these rooms. The coach is in room 1. Player 1 is in room 2. We put player -1 in room 3, and so on. But it's starting to get a little We can't just do this forever. We have to come up with a formula. Now, if we look at the even numbers, I bet we can come up with a formula. What relates these numbers? Well, if I asked you who's in room 12, would you know? I think you would. Room 12, that's player 6. So if you're in an even room, to find out who is in an even room, you just divide the room number by 2. So that's the formula for even numbered rooms. N divided by 2. If I wanted to know who's in room 1000, well, that's player 500. Just divide it by 2. Or you can go the other way around. Where is player 51? Well, don't they have to be in room 102? Do you see how that works? Stop and make sure that you get that. Now, for the odd numbers, it's a little trickier. So the odd rooms, somehow I need to correspond 1 and 0, 3 and -1, 5 and -2, 7 and -3, and so on. And let's go to a new page. What helps me is for the odd numbers, first, take away the signs. See if you can find a way, a relationship between these numbers. So I took away the sign here to try to get an idea how this works. And I don't know how you come up with a formula. Sometimes you just see it. See, these are not quite divided by 2. But if I take, for example, let's focus on this room, room 9. If I take 9 and subtract 1 and then divide it by 2, does that give me 4? Yep. So that's where this in the parentheses comes from. N minus 1 divided by 2. If you take the room number, subtract 1 from it, and divide it by 2, you almost get the number you want. We really didn't want 4. We wanted -4. So I put a little minus sign outside, and that gives me the formula. So let's test this with room 1. If I take the room number, subtract 1, divide by 2, and then I'm multiplying by -1 on the outside, well, this just equals the negative of 0, which equals 0. That works. What about room 11? If I take 11, subtract 1, divide it by 2, and then make that number negative, I would get -5, which is what I want. That's who's in room 11. So this is the formula that creates a correspondence between the rooms and the jersey numbers. Now we know exactly who is in each room. And we have again a one-to-one correspondence. So here we go. This is what the hotel looks like. Every room is occupied and every player room has a room. The coach has her own room, and we also know who is in each room, and we know which room each player has been assigned to. This is a one-to-one correspondence. Now, maybe you're just kind of going along with the story and everything makes sense to you, but stop and think about what we just did. Aren't there more players than rooms? The rooms look like this. The players, on the other hand, well, what do they look like? It goes on forever in both directions. We have all these negative numbers. We have coach 0, and then we have all the positive numbers. Doesn't the set of players look bigger than the set of rooms? What is going on here? Oh dear. Well, I have to fix these symbols for us down here, but that's okay. What have we done? We have created, let's go back and look at that. Do you realize this is the natural numbers? These are the integers. So what we have actually done is create an explicit one-to-one correspondence between the natural numbers and the integers. So what does this mean? This means the set of natural numbers has the same cardinality as the set of integers. Because isn't that what a one-to-one correspondence tells us? If you can create a one-to-one correspondence between two sets, then you know the sets are the same size. They must have the same cardinality. And we call this cardinality, and I'm not too good at drawing this. That's just sort of a terrible version of it. We call this aleph null. This is like the ground level of infinity, we will learn. Aleph null is the size of the natural numbers. Try a better one. And this is what section 3.2 talks about. One-to-one correspondences between infinite sets. That's really the only way that we can describe the cardinality of an infinite set is by using a one-to-one correspondence. What we have just proven is that the integers have the same cardinality as the natural numbers. And I hope that's a little surprising to you. It was surprising to me. Okay, so what are you supposed to take away from the Hotel Infinity? You don't need to memorize this. It's kind of just for fun. But we will have to know how to form a one-to-one correspondence between the natural numbers, and the integers. And we will do that again in the next lecture in a more formal way. Okay, so bye for now.